Map function can be really useful if you don't know how the strings are laid out in the array. So here at Fluke Park, we have a detailed 3-line drawing of this system, but we don't have a drawing detailing where the strings are within the racking. So here, this is very useful to find out exactly where each string is located. The important thing to know with map function is that it's injecting the signal on the positive side and it returns through the negative side. Right now in this combiner box, I have all 3 fuses open for our positive strings. So if I inject the signal into this positive bus bar, it's not going to go anywhere because none of the fuses are closed. So what I want to do is close the fuse for the string that I want to map, and I need to map them out each individually. Um, Map mode uses the auto function for whether it's sourcing the signal from the array or from the unit. An interesting thing with map mode and the other modes as well is it uses an audio signal as an indicator. Um, there's a volume button on the left-hand side of the keypad. I can turn the volume down by single pressing. If I hold it for 3 seconds, it will mute that audio signal. When I turn this on, because it's not connected to the array, because the fuse holders are all open, it will be in unit mode. So the unit is powering the signal and we'll have a distinct audio alarm there. Once I close the fuse, you'll hear that the signal changes because it's in auto mode and it will switch from unit to array. So it's actually powering the signal from the array. So I'm going to go ahead and start the trace. You'll hear the audio signal for unit mode. Then I'm going to insert the fuse and you'll hear that audio signal change. So that's the unit mode signal. If I take my receiver now, I will get no signal on any of these wires. I do get it on the test lead going from the unit because it's going into the positive bus bar. If I insert this fuse, you'll hear the audio sound change. So that audio indicator is for array mode. So it's sourcing the signal from the array. Now I can use the receiver. If I go close to the test lead here, I'm getting a signal there. I can go down here. I can see my signal in that wire there. Because it's so close to these other wires, it will be hard to determine which wire has the signal. So a nice feature about the receiver is you can adjust the sensitivity to the signal, which will allow you to pinpoint which wire has the signal easier. So right now my sensitivity is pretty high. So when I put it in here, anywhere along these 3 conductors, I'm getting signal. Now, if I turn the sensitivity down, and I want to turn it down to where I'm getting about 75, here I go from 99 down to 47. So I'm just going to leave it at the lowest level where it's getting 99. If I move it away from that wire, the signal immediately goes down. So it's much easier to pinpoint exactly which one of the 3 wires has the signal going through it. So adjusting that sensitivity can allow you to pinpoint the exact wire much easier. The receiver also has a line across the top, so you want the wire to be parallel to that line, not perpendicular to it.